in this example, we're asked to consider the vector v given in component form as 2, 3, 3. And we want to find the measures of the angles formed by the following vectors: v and I, v and j, and v and k. In other words, we want to find the directional angles for the vector v. In order to do this, we're going to use the fact that the cosine of the angle between two vectors is the dot product of those vectors divided by the product of the magnitudes of those vectors. Before we get into those calculations, we can record some facts about our magnitudes and dot products that will help us to do the calculations in an efficient manner. For example, in part A, we're going to have to find the value of v dot I. Remember that I is the vector in component form 1, 0, 0. And so our dot product of v and I will simply be 2 times 1 plus 3 times 0 plus 3 times 0, and this will equal 2. We'll notice that this dot product is going to be the first component of v, which is 2, because when we compute the dot product with I, the other components are all multiplied by 0, and our first component is multiplied by 1. Similar calculations will show that v dot j will be the second component of v, which is 3, and that v dot k will be the third component of v, which is also equal to 3. We'll also need to know the magnitude of vector v, which we can compute here. This would be the square root of 2 squared plus 3 squared plus 3 squared. So the square root of 4 plus 9 plus 9, which is the square root of 22. So the magnitude of v will be the square root of 22. The last thing that we need in our formulas would be the magnitudes of I, j, and k, and those require no calculation, as we know that I, j, and k are all unit vectors, and therefore their magnitudes are all equal to 1. Of course, you could go ahead and compute those using the magnitude formula, but because we know I, j, and k are all unit vectors, they all must have a magnitude of 1. So now we have all three of our dot products and all of the magnitudes of the vectors that we're going to need in order to compute the angles between the vectors. First, we'll find the angle between v and I, which we'll call angle A. We know the cosine of A is going to be the value of v dot I divided by the magnitude of v and the magnitude of I. And we've already computed these values. V dot I is equal to 2. The magnitude of v is the square root of 22, and the magnitude of I is equal to 1. And so the cosine of the angle A will be 2 over the square root of 22. The value of A would be the arc cosine of this value. So the arc cosine of 2 over the square root of 22. And this is approximately equal to 1.13 radians, or 64.76 degrees. So the angle between vector v and the standard unit vector I is either 1.13 radians or 64.76 degrees. We do a similar calculation to find the angle between v and the standard unit vector j. If we call that angle b, then we know that cosine of b will be the dot product of v and j, which we know is 3, divided by the magnitude of vector v, which is the square root of 22, and the magnitude of j, which is 1. And so our cosine would be 3 over the square root of 22. We find b by taking the arc cosine of this value. So b will be the arc cosine of 3 over the square root of 22. And this is approximately equal to 0.87 radians. Or, if we prefer degrees, approximately 50.24 degrees. And so this will be the angle between vector v and vector j. And last but not least, we want the angle between vectors v and k. Here we have the cosine of our angle c as the dot product of v and k over the products of the magnitudes, which would be the square root of 22. So we have cosine of c equaling 3 over square root 22. And here we have c will be the arc cosine of this value. You'll notice that this is the same as angle b because the dot products of v and j and v and k are both the same. And so we get 0.87 radians or 50.24 degrees. And so the angle between v and k is 0.87 radians or 50.24 degrees. Next, we want to perform the same calculation with a new vector, this time with the vector v given in component form as 3, -5, 1. Here we want to find the measure of those angles formed by the vectors v and I, v and j, and v and k. You can pause the video and try the example yourself, then resume the video to see the solution in a few seconds. We start by computing all of the dot products and magnitudes that we're going to need for the calculation. Like before, v dot I is going to be the first component of vector v, which is 3. v dot j will be the second component, which is -5. And v dot k will be the third component, which is 1. The magnitude of v is easily computed using the magnitude definition. This would be the square root of 3 squared plus -5 squared plus 1 squared, which is the square root of 35. And the magnitude of I, j, and k will all be equal to 1, since those are all unit vectors. We now use all of these values to find the angles between the given pairs of vectors. If we let a be the vector between v and I, then the cosine of a will be the dot product of v and I over the product of the magnitudes of v and I. This would be 3 over the square root of 35. The angle a is then the arc cosine of 3 over square root 35, which will be either 1.04 radians or 59.53 degrees. A similar procedure will find the angle b between vectors v and j. We first find the cosine of angle b to be the dot product of v and j over the product of the magnitudes of v and j. This will be -5 over the square root of 35. We then find the angle b by taking the arc cosine of -5 over square root 35, and we obtain 2.58 radians, or 147.7 degrees. And last but not least, we find the angle c between the vectors v and k by first finding the cosine of c. This is the dot product of v and k over the product of the magnitudes of v and k, which end up being 1 over the square root 35. C is therefore the arc cosine of 1 over square root 35, which is approximately 1.4 radians, or 80.27 degrees.